going to write a system of linear equations as a matrix equation. So this kind of brings us full circle from the Envision's algebra to system of equations we learned previously into how we could do this by hand. So we've done this before by calculator, but now we get to see how to do this by hand. All right, so what we're going to start out with is a system of equations. That's what we need. So we're going to have A, and our two equations here are going to be 3x minus 5y equals 7, and 2x plus 1y equals 4. And the coefficients of these matrices has rows which contain the coefficients from a single equation. So what we want to do is make sure that our x coefficients and our y coefficients line up. So again, 3 is my x, 2 is my x, 5 here is my y, 1 here is my y, and then 7 and 4 are my solutions. So I got to make sure that they line up in that fashion. So each column contains all coefficients of a single variable, so we want to make sure they line up so the columns could contain a single coefficient. And the coefficient of y in the second equation is 1. So that's 1y. It's supposed to just be y, but we're going to put a 1 there so you can see what's happening. And so what we're going to create is a variable matrix. And a variable matrix, V-A-R-I-A-B-L-E matrix, has one column, has one one column that represents all the variables. All the variables in the system. Of the equations. T-I-O-N-S. And the variable matrix is sometimes called a variable vector, so sometimes this is replaced by vector, but it's the same idea. So we're going to use the constant values from the right-hand side of the equation to make the constant matrix. All right, so what we're going to do here is we're going to have 3 and 2, and 5 and 1 for that matrix. That was supposed to be yellow, so I'm going to grab yellow. And what we're going to multiply this to is xy. Because again, we're looking at x and y's here. When we multiply, we'll get this kind of system here. And this is going to be equal to the matrix 7, 4. Okay, now we have to solve for x and y here. So what we can do is, so we now did it in a matrix. So what we can do now is take a step back. We could find the inverse of each side, and we can begin to get our 1s and 0s and solve for x and y. So just a quick way to give you the ideas. We've done this in a previous example where we have a negative 1 times a times x equals b. And from this, we would basically solve for x and y. All right. But in this one, we're just showing how you can use a system of linear equations to represent a matrix equation. So there is our matrix equation. The second one, we're going to look at something a little bit bigger. We're going to look at x minus 2y plus 4z equals 9. 2x minus 8z equals negative 24. And 3x plus y minus 2z equals negative 1. And again, we're just going to see how we could represent this in a matrix. So again, looking at this, I'm going to go with my x values, 1, 2, 3. My y values, 2. We don't have a y in this one, so this is missing y. Which means that we must have a 0 times the y. And because we don't write zeros down, our y in the second equation is just going to be 0 and then 1. And then third one is 4, -8, -2. Now what we're going to do is we're going to write our second matrix, x, y, and z, to show our matrix right out here. And then our solutions, 9, -24, and -1. So again, these guys are represented here. My y's and my lacking of y is represented here. Lovely, lovely circles. And my z's are represented here. Beautiful art. This should be hung in a art gallery. But this is just the simplistic way. We're not solving this right now. We've looked to see how we solve things in a previous example. If you want to go and try to solve these, you can try that example and get your skills a little bit further up. But again, in these examples, we're just basically doing the foundations to writing the system of equations into matrices so that we can start to solve them. All right, guys, so if you have any questions, always feel free to ask. If you want a print of this beautiful art, I'm actually just going to delete it right after this, but I will catch you in the next video.